Light. Light is form of energy. Light is needed to see things around us. Light enables us to see objects from which it comes or from which it is reflected. We detect light with our eyes. Light travels along a straight line. Take 3 rectangular cardboards A, B and C. Make a small hole at the center of the cardboards at the same horizontal level. Place the 3 cardboards horizontally in such a way that the 3 pinholes are in a straight line. Place a burning candle on one side of cardboard A at the level of hole. Now make sure that you have arranged the 3 cardboards and a candle in such a way that the 3 pinholes and the candle flame are exactly in a straight line. Now observe the candle flame through the hole of the cardboard C. You will be able to see the flame of a candle as the holes are in the straight line at the level of the candle. Now slightly displace any one of the cardboards and try to see the flame through the hole of the cardboard C. The flame will not be visible. Hence we conclude that light travels in a straight line. This is known as rectilinear propagation of light. Reflection of light. You have seen that light travels in a straight line. Now let us see how we can change the direction of light and what happens when light falls on a polished or shiny surface. Definition. When light ray strikes the boundary of two media such as air and glass, a part of light is turned back into the same medium. This is called reflection of light. A highly polished surface such as mirror reflects most of the light falling on it. Laws of reflection. 1. The angle of incidence is equal to the angle of reflection. And 2. The incident ray, the normal to the mirror at the point of incidence and the reflected ray all lie in the same plane. These laws are applicable to all types of reflecting surfaces, including spherical surfaces. Types of reflection. The types of reflection are of two types: regular reflection and irregular reflection. Regular reflection. It occurs when a beam of light falls on a smooth and polished surface such as a plane mirror. Irregular reflection. It occurs when a beam of light falls on a rough surface such as a wall of room. Incident ray. Light ray striking a reflecting surface is called incident ray. Point of incidence. The point at which the incident ray strikes the reflecting surface is called the point of incidence. The light ray obtained after reflection from the surface in the same medium in which the incident ray is traveling is called reflected ray. The perpendicular drawn to the surface at the point of incidence is called normal. Angle of incidence. The angle which the incident ray makes with the normal at the point of incidence is called angle of incidence. It is denoted by the letter I. The angle which the reflected ray makes with the normal at the point of incidence is called the angle of reflection. It is denoted by the letter R. The plane containing the incident ray and the normal is called the plane of incidence. The plane containing the reflected ray and the normal is called plane of reflection. Plane mirror. When an object is held in front of a plane mirror, a copy of the object is visible in the mirror. The copy of the object in the mirror is called its image. When you look into a mirror, you see your image in the mirror. An image can be real or virtual. Real and virtual images. Let us discuss what are real and virtual images are. Images which can be formed on a screen are real. For example, images formed on the cinema screen is real. Images which cannot be obtained on a screen are called virtual. Example, images of our face in a plane mirror is virtual. Lateral inversion. When an object is placed in front of a plane mirror, then the right side of the object appears to become the left side of image and the left side of the object appears to become the right side of image. This change of sides of an object and its mirror image is called lateral inversion. Curved mirror. Spoon has two reflecting surfaces, one curved inside and another curved outside. Now the specific type of curved mirror that we are interested in are called spherical mirrors. In fact, these two mirrors are spherical. Why they are called spherical mirrors? They are called spherical mirrors because their reflecting surface is a part of sphere. You can clearly see that the reflecting surface of both the mirrors form the part of the sphere. Now, both these are given special names. The mirror that has its reflecting surface curved inwards is called concave mirror, and the mirror having reflected surface curved outwards is called convex mirror.
Topic: concave mirror. Why is your reflection upside down on a spoon? Wow, looks like you're getting ready to go for a party. Why don't you stand here and then look into the spoon? Don't worry, your image appeared upside down because of the inward curve of the spoon. The surface of the spoon, which is curved inwards, acts like a concave mirror. You look confused. Let me explain. A concave mirror is a mirror whose reflecting surface is curved inwards. Being curved inwards, it reflects or bounces back the light rays in a different manner. When you see yourself in a spoon, which is like a concave mirror, the light rays from your face fall on the top of the spoon and get reflected downwards, while the light rays from your feet fall on the bottom of the spoon and get reflected upwards. As a result, you see yourself upside down. Now, the point where all these light rays meet is called the focal point. When you stand beyond this point, only then will you be able to see an inverted image of yourself. However, if you stand before the focal point, the image will look upright.
Concave mirror is used by dentists, and it is also used in vehicles' headlights, in shaving mirror, telescope, and etc.
Topic: convex mirror. Why is a convex mirror used as a rear view mirror? Wow, what an amazing car! But your rear view mirror is missing. No, don't use a concave mirror. It will usually show you magnified images.
Oh.
Why don't you listen to me? See, I was correct. Now put the convex mirror and see the result.
Oh.
Look, the image is much smaller, right? Do you know what the difference between the two mirrors was? If we use a concave mirror for our car, we will not be able to see the vehicles behind us properly. This is because the concave mirror will magnify the object and we will see a very enlarged image. Thus, we require a mirror which gives us a wider view of the vehicles behind us. In this case, a convex mirror proves to be the right choice. This is because a convex mirror forms a highly diminished image, thus making the traffic look much smaller. As a result, we can see a large number of vehicles in a very small mirror.
Convex mirrors are used in microscope, eyeglasses, cameras, magnifying glasses, and etc. Sunlight, white or colored. You must have seen street lamps that give yellow light. The yellow light looks quite different from sunlight, which is colorless. Light that is colorless is called white light. As the sunlight passes through the prism, you will observe a beautiful band of colors appearing on the white sheet. If you look at these colors of the band from the bottom, they are in the order violet, indigo, blue, green, yellow, orange and red. This sequence of colors can be remembered by the short form VIBGR. Light coming from the sunlight was white light. Are you wondering from where this beautiful band of colors appeared? Actually, the white light consists of 7 colors, namely violet, indigo, blue, green, yellow, orange and red, which we saw as the band of colors. When the white light coming from the sunlight falls on the prism, it splits the incident white light into constituent colors. The splitting occurs because different colors of sunlight bend through different angles with respect to the incident ray. When they pass through the prism, the red light bends the least while the violet bends the most. Thus, the rays of each color emerge along different paths and become distinctly visible. Thus, we are able to see the beautiful band of colors. This phenomenon of splitting of white light into its constituent colors through a prism is known as dispersion of light. The band of constituent colors is known as spectrum. This phenomenon was first discovered by Sir Isaac Newton. Now that we have understood what dispersion of light is, let's understand how it causes the formation of rainbow. A rainbow is generally formed when the sun appears just after it has rained. At this time, many water droplets are present in the air. When the sunlight passes through water droplets in the atmosphere, each water droplet acts like a small prism and refracts the incident sunlight. As soon as the sunlight enters into the prism, that is the drop, it splits into its constituent 7 colors VIBGR within the drop. When this band strikes the other edge of the drop, it gets reflected internally towards the first edge of the drop. As the band reaches the first edge, it gets refracted again and finally comes out of the raindrop. This band of colors which finally comes out of the raindrop is what we see as a rainbow. A rainbow is always formed in the direction opposite to that of sun. Thus, the appearance of rainbow in the sky is due to the dispersion of sunlight by the water droplets present in the atmosphere. Dispersion of light not only results in the formation of a rainbow, but we can see this effect in our day-to-day life as well. For example, the beautiful band of colors we observe in water fountains, soap bubbles, CDs are all due to dispersion of light. Newton's disk. If white light is made of lights of 7 colors, then the 7 rainbow colors can be recombined together to form white light with the help of Newton's disk. The way light mixes was first explained by the famous English physicist Isaac Newton. He showed that on rotating a rainbow colored disk, it appears white.